3.7 Graph linear functions. The function notation is represented by f of x equal to mx plus b. The symbol f of x is another name for y and is read as the value of f at x, or simply f of x. It does not mean f times x. Any letter such as G or H can be used to name functions. Family of functions is a group of functions with similar characteristics. So, for example, any linear function with the following model, f of x equals mx plus b, will be considered a family of functions because they all have the graph of a line. The parent linear function is the most basic linear function, f of x equals to x. So the graph of the parent linear function is what we have here in the picture to the right. It looks like a line that cuts the xy coordinate plane in half. Okay, let's look at some functions, comparing graphs of linear functions with the graph of f of x equals x in more detail. Changing m, let me make this bigger. Changing m, the slope, or b, the y-intercept in the general linear function, g of x equals mx plus b, creates families of linear functions whose graphs are related to the graph of f of x equal to x, which is the parent linear function. So let's take a look at g of x equals to x plus b. Here you're given 3 lines. The one in the middle will be your parent linear function. So we could write that as g of x equal to x. And the line to the top has been shifted up 2 units. So we can write that as g of x equal to x plus 2. And the line to the bottom has been shifted down 3 units. So we could write that as x minus 3. As you can see, they all share the same slope. The graphs have the same slope, but different y-intercepts. Graphs of this family are said to be vertical translations of the graph of g of x equal to x. And let's take a look at the case when g of x equals to mx, where m is positive, or when the slope is positive. Okay, so for the parent graph again, and still g of x equal to x, if I rotate the graph to the left, the graph becomes g of x equal to 2x. So it's actually a dilation. I'm going to write the word dilation. Of the parent graph by a scale factor of 2. And the other one will be g of x equal to 2x, 1 over 2x, excuse me. And this would be also a dilation of the parent graph by a scale factor of half. So the graphs have different positive slopes, but they have the same y-intercepts. Graphs of this family are what we call vertical stretches or shrinks of the graph g of x equal to x. So you could simply say vertical stretches or shrinks as dilation when you're describing how the graph has changed compared to the given parent graph. And let's take a look at this one. G of x equals to mx when the slope of m is negative. Okay, so our parent graph again is g of x equal to x. Okay, if we rotate the graph further left so that the graph is reflected around the x-axis, we can see that for this graph, g of x has become negative x. And if it shrinks, then the graph will be negative 3x. So the graphs have different negative slopes. But the same y-intercept. In this case, 0, 0. Graphs of this family are again vertical, stretches, or shrinks with reflections in the x-axis of the graph of this case g of x equal to x. Okay, now that we looked at the components of functions and the family of functions compared to its parent linear functions in detail, we can now practice problems involving functions. So evaluate the function when x equals to negative 3, 2, and 4 and 5 tenths. So all you have to do is substitute x for negative 3 and find the value of f of x when it's negative 3, 2, or 4, and 4.5. And for this one, same thing. H negative 3. So this got to be careful. Negative negative makes positive, so positive 30, so 38.5. And h is 2. So 10 times, negative 10 times 2 gives negative 20. Negative 20 plus 8.5 is negative 11.5. And h at 4.5 is 10. You can shift the decimal one place to the right, so 45. And then we have negative 36.5. Here in part B, for the given function, find the value of x so that the function has the given value. So basically, here negative 7 will be our f of x. And we need to find out what x is. Then again, 26 equals 14 minus 4x. Equals negative 3. Part C, graph the function. Compare your graph to the graph of f of x equal to x. So here, I'm going to use slope-intercept form. I know my y-intercept is 0, 3. My slope is 1. Shift 1 up to 1 to the right. Remember, 1 over 1. Okay, and then I can graph my function. So you can describe this as the graph of g of x. So this is the graph of g of x, is the graph of f of x shifted upward 3 units. For the next one, we have 0, 0 as our y-intercept. The slope is 2 over 1. I'm going to shift 2 units up and then 1 unit to the right. And now I can connect my points. And if I graph the parent function, that location, so I can say, make this bigger, the graph of h is a dilation of the graph f using a scale factor 2. What if this graph is h of x, or function is h of x equal to negative 2x? Then your graph will look like this. And to describe this, we need to continue with what we've described here and write and a reflection of graph f about the x-axis. So this part is only for when you have a negative slope. But when you have a positive slope, you write this part. And then again, when you have a negative slope, you include everything here and all the description you have here. So I would say I'll circle everything in black for h of x equal to negative 2x. And everything in red for h of x equals to 2x. Okay, let's take a look at one word problem here. The number of hours people in the United States spent using the internet each year from 1998 to 2001 can be modeled by the function f of x equals to 26.4 x plus 54.4, where x is the number of years since 1998. So we can say that 1998 will be year 0. Part A, graph the function and identify its domain and range. So your function is represented by this model here, and you know this is the y-intercept, and this is your slope. Okay, we could take 54.4 and add 26.4 to find the shift, vertical shift. Okay, so the vertical shift will be 26.4 units up and 1 unit to the right. Okay, so let's see, 54.4 is about right here, and after shifting 26.4 up, we get about 80.8. That's about here. I'm going to shift that 1 unit to the right. Okay, and I know that my final year is year 3. So when f of 3 what's my value when during year 3 will be 79.2 plus 54.4, and that would equal to 133.6. So in year 3 it's about here, so 3 133.6, and I can draw my graph. Okay, and this is 0, 54.4, and I can write my domain. 0, year 0 to year 3, inclusive, and my range would be 54.4 f of x to 133.6. Now find the number of hours that people spend on the internet in 2000. So 2000 will represent year 2. So 2 years. F of 2. So we need to find the value at f of 2. And that would equal to 107.2 hours. Part D. When did people spend about 120 hours per year on the internet? So we need to do just the opposite. Actually, this is part C. Okay, we have to take this function here. And now we need to find x. So our value is 120. F of x is 120. And we can take the inverse of 54.4 and subtract it to both sides. So this goes out. And 120 subtract 54.4, we get 65.6 equal to 26.4x. X equals to 656 over 264. And after you simplify this, you should get somewhere around 2.5. Okay, and how do we read this? This means 2.5 years. So recall from part B that 2 years represents year 2000. So we can say 2.5 can be translated as middle of 2000, or halfway through the year 2000. Okay, and that's it.